Hello everybody, I will start my today another coding practice. So today I solved this question, coin change. And actually this is my second video on this question. So this is a quite famous dynamic programming question. And in my first video, I solved this with top-down dynamic programming. And in this video, I will introduce the bottom-up dynamic programming approach. Okay, so let me quickly read through the question statement. Oh, by the way, I mean, implementation written in the editor is the top-down one. Yeah. So maybe I can reference this while implementing the bottom-up approach. So I just left it. Okay. So in this question, I'm giving an integer array coins, and this represents coins of different denominations. And I'm also giving an integer amount. This represents a total amount of money. And my task is to return the fewest number of coins that I need to make up that amount. Okay, so I try to make up the given amount with coins, and I return the minimum number of coins to make it up. And if that amount of money cannot be made up, then I will return -1. And I can assume that I have an infinite number of each kind of coin. Okay, good. So, yep, this is a question. So again, for example, 1, I try to make the total amount, $11. And I have $1 coin, $2 coin, $5 coins, infinite number of coins. And I try to make up $11 with $1, $2, $5, and I will return the minimum number of coins I need to make it up. So in this case, if I choose $5, $5, and $1, it costs 3 coins, and that's the minimum number to make up that amount. So I return 3. Okay, so now I will quickly wrap up review the implementation of top-down dynamic programming. So in my last video, I introduced 2 interfaces for top-down DP recursive functions. The first interface was this, and the second interface was this. So in my first interface, the argument was only amount, and I tried to find the minimum number of coins to make up this amount, allowing any coins to be used. And in the second interface, I passed not only amount but also coins. So in this approach, I tried to reduce the options of coins one by one. Yeah, in each recursive function. So these were 2 approaches I made. And in this video, I will implement the bottom-up dynamic programming implementations. And probably I will implement 2 approaches. One corresponds to this, and second corresponds to this. Okay, so that being said, let me get started. Yep. So in the bottom-up dynamic programming approach, I will think of the amount. Okay, I will think with this example again. So I will try to see if I can make up amount 0, 1, 2, 3, 4, blah, 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 until 11. So my task is this. So in the bottom-up DP approach, I will try to create this 0. This is possible or not, and how many coins does it require to make it up at minimum. So this should be obviously 0. I don't need any coin. And next, to create $1, I have three choices. Yeah, choosing $1 or choosing $2, choosing $5. I have three options, and if I choose $1, the remaining is $0, and the minimum number of coins I need to make up $0 with 0, so it should be 1. Then next, if I choose $2, this isn't possible because I try to make up $1, which is less than $2. Yeah, first $5, the same. So now I move the pointer to $2. So far I can say to make the $0, I need minimum 0 coins. And for $1, minimum 1 coin. This is already determined. I have no other way to make up with smaller amount, smaller count. Now I will think of this $2. I think this from here it's becoming more interesting. So I will think of three options: $1, $2, $5. And if I choose $1, the remaining $1. So, and for $1, the minimum number of coins to make up is 1 coin. So this should be 1 plus 1. Yeah. So next, if I choose $2, I learned from the previous answer, previous results, that to make it to $0, I need 0 coin. So this should be 0 plus 1. So minimum sum is 1. So I can say I can make up $2 with minimum 1 coin. Okay, that's the thing I can say. And I do this, until amount $11. Yeah, row by row, one by one. The DP table is, filled in. So let me name it DP because the intention is super clear. Okay, now I start implementation. Oh, and obviously for this, the time compressed should be assuming I have n coins and amount is m, it should be nm. Because I have to fill in the DB table whose rank this is m. And to fill in each cell, I have to iterate with each coin existing. Yeah, so it should be n. So the time complexity should be n times m. And for space complexity, obviously I need the DB table, which is O of m, and that's it. Okay, so that's the implementation. Mm. Okay, from here, I will fill in the DB table, DP amount cell. Okay, let me put mass.infinity. This means that I cannot generate, the amount of that cell. This makes the implementation easier. Okay. So in line 42 for each coin, So indentation indentation is something strange. Okay, this is it. So let me quickly explain my code. So firstly, I initiated the DP table. Yeah. So DP0, it always 0 because I don't need any coin to make up $0. Then aside from that, I just initiated with master the infinity. Yeah. I can assume this that if I cannot make up the amount, it should be master infinity by default. Okay. And in line 42, I check each amount, and for each amount, I will check each coin, and if the coin exceeds the amount, I skip it. But otherwise, my task now is to create amount minus coin. Yeah. So I take a look at DB table to find the past result and increment by 1. This is the coin I've chosen just now. So this is how I get the number of coins. Then I will update the DP amount with this, number coins. Okay, looks good. Let me run my code. Okay, I submit my code. Good, accepted. Okay, so this is the first, interface I've implemented. No, so I mean, this corresponds to the first interface of the top-down DP approach. And now I will think of the second approach. Okay, so this becomes a bit more complicated. And actually, there's no benefit to choose this approach, but just for my practice, I will implement this. So in this approach, I will make this DP table, 2D. Okay, so I will think which coin I can use in the vertical axis. And in the horizontal, I will think which target amount I'd like to make. Okay. So now I will fill in this table, and what I like to get is this. Fill in this each cell with the minimum number of coins to make up the amount with the possible coins. And obviously, what I want to get is this one. Make up $11 with all the coins, 1 to 5. So when I try to think of this, so for the first, coin, I see. So let me think how. Okay, sorry. I need 0 also. Let me 0 amount. Okay, let me think. For example, I try to fill in this cell. In this case, I try to make up $1, $2, or $2 with $1, $2. And I can say, if I choose $2, it comes from here. Okay, sorry. Let me think with an example that I don't choose $2. If I don't choose $2, it comes from here, because I just have to forget the $2 and try to make up $2 is only $1. So this should be just above the current cell. So this is X. Also, I will think, if I choose one $2 coin, it comes from here, +1. So to fill in this, if I try to make up $2 with $1 coin or $2 coin, it should be the minimum of X and Y +1. X is the case when I don't choose $2, and Y is the case if I choose $2. So you may think, what if I try to choose $2 twice? In that case, this here, Y, doesn't limit $2 coin. I can still use $2 coin to calculate Y. So it doesn't, it is, this approach covers the case when $2 is picked up multiple times. Okay, so this is how I fill in the dynamic programming table, 2D. Okay. Good, so let me work on the implementation. Okay. Oh, and the time complexity should be O of NM, because I tried to fill in NM cells, and for each, to fill in each cell, it takes only the constant time. And for space complexity, I need to build in 2D table, so NM. I actually don't have to keep track of all the rows. If I fill in this row, all I want is only the previous row. So one optimization I can make is to make this O of M, because I have to keep only 2 rows at max, which is 2 times M. But I don't do it in this video. Okay. Now I start implementation. Oh, sorry. On my second thought, I will do that yeah. No, okay. I think one optimization I can make, one implementation technique I can use is just fill in here. I will think of the row which corresponds to the case when I don't use any coin. In this case, this should be 0. And aside from that, all would be impossible. This should be like this. Yeah. But with this will help the first row, second row, in which I choose only one coin. Because here, when I try to fill in this row, to make up 0 coin, I will look up and I get 0 from here. And when I look up, this is infinity. But when I look right, I get 0. So this should be 1. Then when I try to fill in this cell, I first will look up and the result is infinity. And when I take a look at the left, I find 1. 2 minus 1 is 1. So I get 1 plus 1 is 2. So I can easily fill in this cell in a generalized way. So that's what I will, do. Okay. So this is the initialization of the DP table. Okay. So I will think how many first coins I can use from 1 to n. Then when I choose one coin, wait a minute. And coin options. Okay, so let me change it to row. This is a row in the DB table. So what happens is that the current coin should be this. Okay. So and I fill in the table. So DP current row. Okay, and then I will try to fill in column. 0 to amount plus 1. No, 0 to amount. And here. Okay, now I'm taking a look at each cell. And for each cell, what I will do is, as I said, I will look up first. Like this. And also, so this is a and I will think of the case if I choose one or more current coin. Like this. However, this is possible only if current column, which is amount, is more than the or equal to the current coin. Okay, so this is it. Good. In the end, I will return dp the Rust row, Rust column. But I have to convert mass infinity to -1 because mass infinity signifies the case when the amount cannot be generated. And in that case, from the question statement, I have to return -1. Like this. Okay. So let me quickly review my code. So in line 60, I initiated the DB table. Yep. And I filled in 0 with 0. Okay. And I start from row number 1 to the end final row. And for each row, there is a corresponding coin. So I will take a look. And from that coin, I will try to make up the amount. Let me change seed amount. Okay. So I will think of the first case. I don't choose the current coin. In that case, I will just look up the cell above. Good. And also I will, if I choose one or more coins, I will look left. Yep. In this way. So I choose my current coin plus I try to make up amount minus coin with still the same options of coins. Okay. And finally, I return the, right bottom cell. Okay, I submit my code. No. Okay, so let me see what happens to the DB table in the end. Oh, seems like the left, first column is always 0, which is good. But aside from that, it's not met, updated. So in line 65, no. Wait, maybe in line 69, something is wrong. If coin is less than current amount, oh, this should be max. No, this should be mini. Okay. 1 plus DP row amount minus coin. Yes. Let me think if it really, goes through here. Yes, it does. Wait, so coin amount is sometimes 5 and 10, so it's smaller. I will take a look what each cell is updated with. And like infinity, always. But in some cases, I think this should be 0 because here in the first column, it's 0. Wait, I found the why. Reason why. This should be coin is equal or smaller than the amount. So if coin is exactly the amount, I can choose that coin and the remaining should be 0. And that's the base case I've already filled in as 0 in the column 0. Okay, so I'm pretty sure this works with this. Good. Okay, I will submit my code. Good, accepted. Okay, so I will quickly wrap up on today's coding practice. So today's question in today's video, I solved the question coin change. This is a quite famous dynamic programming question. And in my last video, I solved this with top-down DP. And in my current video, I solved this with bottom-up dynamic programming. And for each, I implemented in 2 approaches. So in total, I implemented this with 2 top-down DP implementations and 2 bottom-up DP implementations. Okay. So yeah, this is good. And yeah, in this bottom-up DP approach, as I said, I introduced 2 approaches. The first one is the one in which I used the 1D DP. Yeah. So I try to make up each amount from 0 to the given amount. And to find that, I think which of all the coins I should choose to make that up. Yeah. So in that way, I use the 1D DP, and to fill in each cell, it took all of k time. So it took in total, all of number of coins. So in total, the time complexity was number of coins times amount. And the second DP approach, I introduced the 2D DP and the vertical, vertical axis. I mean, each row suggests each row suggests or represents possible coins I can choose from, and each column represents target amount I'd like to build. And I try to fill in all of these 2D cells. I mean, all of the cells in this 2D DB table. And finally, I return the right bottom cell result. And one thing I had to take care of that, I had to fill in each cell in the constant time. So for each cell, I looked up the cell above and the cell on the left-hand side. This is the kind of optimization I can make. I actually didn't show the naive approach, so you wouldn't know the value of this, technique. But if you look at the, top-down programming video, you will know Yeah, that. So if I don't use the technique, the time complexity should be O of n m squared, and it gets TLE. Yep. So that being said, I finished my today's coding practice. Thank you so much. Bye.